This is the general equation for the area of a polygon of n sides inscribed in a circle with a radius of 1. The variable a stands for the area of the polygon, and n is the number of sides in the polygon. So to find the area of a polygon, we are going to use the pentagon as an example. So pentagon has 5 sides, and so I've created 5 triangles. Divide the triangle in half, and so each one of those bigger triangles angle is 72, and the smaller angle is 36. The radius is 1, and so the hypotenuse of this triangle is 1. So sine of 36 equals opposite over hypotenuse, and so that's n over 1. To find the height of this triangle, you would use cosine of 36 equals adjacent over hypotenuse, hypotenuse being the radius 1. To figure out the area of the triangle, use the formula 1/2 base times height. And so the area of this pentagon is 1/2 2 sine 36 cosine 36. And so the reason why it's 2 sine 36 is because when we were solving for n, we only solved for half of the triangle, and therefore we need to times 2 for the entire base of the triangle. And so 1/2 and 2 cancel out, and so the area of one of these 5 triangles is sine 36 cosine 36. And since we're trying to solve the area of the entire pentagon, we need to times the area of the triangle by 5. And so the area of the entire pentagon is 5 sine 36 cosine 36. And so if we were to put this formula in terms of n, 5 would be the number of sides of the polygon, and 36 would be the angle of the inner sides of the triangle. And so that would be 360 degrees divided by 2n, and that would be 180 over n. And so the final equation, as I have stated earlier on this video, would be n sine 180 over n cosine 180 over n. And so here we have a circumscribed polygon in which the radius of the circle is 1. And so in order to find the area of this circumscribed polygon, as we have discovered previously in this video, the angle is 36, and so therefore tan of 36 is opposite over hypotenuse. Adjacent, and so that would be x over 1. Now since x is only 1/2 of the base, we need to times x by 2, the height being the radius is 1. And so therefore the equation is 1/2 base times height, which would then equal 1/2 2 tan 36 times 1. So now that we have figured out the area of one of these triangles, we will times it by 5 in order to find the area of the entire polygon. And so the A, of course, stands for the area. The 5 is the number of sides in the polygon, and the 1/2 and 2 cancel out. And so if you plug in n, the equation would be A equals n tan 180 over n, and the 180 over n being 360 over 2n simplified down. So the inscribed and circumscribed polygons differ in that in this one, the radius, the radius, which is also the hypotenuse, is 1, and so therefore you would use sine and cosine. And in this one, you know that the radius is 1, but because it's not the hypotenuse, you would use tangent.
So some connections that I saw while working on this approximation of pi lab was that for each particular n, the circumscribed area is always closer to pi than the corresponding inscribed area. And also, the circumscribing regular polygon around the unit circle will overestimate the value of pi, whereas the inscribed regular polygons will always underestimate the value of pi. So when I first did this problem, I used a more complex method in which I used I figured out the outer angles of the polygon by using the equation 180 times n minus 2, and that equation was a bigger hassle, and so by using problem-solving strategies, I discovered that there's an easier solution to this problem in which you just divide the 360 by the number of sides.